Hi everyone and welcome back to another video. In this session we're going to be working out the equivalent capacitance of this circuit and the energy within the circuit. So to begin with, let's look at a few rules. For capacitance in series, we take the reciprocal. So this is opposite to resistors in series. Now in parallel we add the capacitance. So the first bullet point is capacitors in parallel. Now we take the reciprocal, which is these two bullet points, when they are in series. So it's opposite to resistors. If you haven't seen that video, please do check it out. I've created a video on working out equivalent resistance of circuits for both series and parallel. So let's begin. We've got a voltage source of 1000 volts. The current leaves the voltage source, so let's just assume clockwise. Current leaves, it goes across this 2 microfarad capacitor, gets to this node here, and then therefore current can split either going forward, straight ahead, or going down. So therefore these two are in parallel. Now once the current goes into this circuit here, we've got current either going straight across this node or going down. So therefore again we've got a parallel branch between these two, as the current can only go in one direction. Through this branch, this is the only one in series, and then these two are in parallel as we have a current divide. So therefore this 2 farad and this 2 farad capacitor are in parallel, so we can work out the equivalent capacitance, which is according to here is just going to be 2 plus 2. So that's going to be 2 plus 2 is equal to 4. Now this equation, so this diagram can be rewritten or redrawn something looking like this. So everything else remains the same, but here that 2 plus 2 now becomes 4 farads, which is here, and everything else as usual becomes the same. So this is quite a rough drawing, but you get the idea, and everything else remains the same. Now if we look at current at the right hand side, so away from the power source, which is a really good place to start, once the current splits at this node, so either current can go straight as discussed, or it can go down. So if the current here, let's just call this current X, the current X here can only go in one direction in this loop, which is around, down, back around. So therefore these 3 capacitors are now in series. So therefore what do? We take the reciprocal, and here we've got 1 microfarad, the equivalent 4 microfarad and 1 microfarad. So therefore the equivalent resistance CT is equal to 1 over 1 times 10 to the power of minus 6 plus 1 over 4 plus 1 over 1 times 10 to the power of minus 6. And what we do is we take the reciprocal of all of that. Now what I'm going to do is just quickly move this downwards so we can see it. And then what we do is we take the reciprocal as mentioned, so all of that, and that's going to equal to 0.5 microfarads. So let's redraw that circuit again. So what does that look like? We've got the power source, we've got the 2 microfarad capacitor, we've got a 500 nanofarad, we've got a 2 farad capacitor, and then these 3 now become 0.5 microfarads. So remember how we said current at this point gets split, so it can either go straight across or down. So therefore these 2 branches are now in parallel. So therefore we've got a 500 nanofarad and a 0.5 microfarad. So what's the equivalent resistance? The equivalent resistance of them is just going to be the summation. So that's going to be 0.5 times 10 to the power of minus 6 plus 500 times 10 to the power of minus 9. And that's going to equal to 1 microfarad. So now let's just quickly just clear this up. So what I've done is just clear the screen up. Let's redraw the circuit diagram. So as discussed, we've got a 2 microfarad. Now the 500 plus the equivalent resistance of all of this on the right hand side, which is just all of this, has worked out to be 1 microfarad with the 500 nanofarad in parallel. So that becomes 1 microfarad. Now for the final circuit looks something like this. We've got 2 microfarad, 1 microfarad and 2 farads. So therefore the equivalent resistance CT is equal to the reciprocal of each, which is 1 times 10 to the power 2 to the power of minus 6 plus 1 over 1 times 10 to the power of minus 6 plus 1 over 2. Again, we take the reciprocal to get the final answer, and therefore CT is equal to 0.67 microfarads. So that's going to be the final circuit, which is going to look something like this. You've got your power source, 1 capacitor, and the final closing, which is 0.67 microfarads. So how do we find the energy of the circuit? The energy of the circuit E is given by half times the final capacitor CT times by V squared. So we've worked out CT final to be 0.67 microfarads, so we just plug that in. So half times 0.67 times 10 to the power of minus 6 times by the voltage of the circuit, which is 1000 squared. And that means E is equal to 0.33 joules. So I hope you've enjoyed that video. If you did, please give it a like, and please do subscribe, as that helped me out quite a lot. Take care, people.